Assalamu alaikum. This is a solution of some questions on vectors for grade 11S. Let's start question number 1. Fill in the blanks with integers. Some may be negative. I have a coordinate of point A and C, and this vector EB is given. From this vector, we can use it to find the coordinate of point B. For example, the vector AB is simply OB minus OA. The vector AB is given -5, 1, -3. This vector equals OB, I don't know, minus the vector OA is 3, -2, and 1. So this implies the vector OB. Vector AB means the position vector of point B on space. OB now is the sum of this together. These -5, 1, -3, plus 3, -2, and 1. Okay, -5 plus 3 is -2, 1 plus -2, -1, and -2. Okay, now I can find 2AB plus CB. First, the vector CB, you can find it now. OB minus OC. The OB, I have it now, -2, -1, -2, minus the C here is 4, -3, and 0. Answer is -6, 2, and -2. Now I can find now this part. I want to find the value of 2 vector, or the vector 2AB plus CB. The AB here, as you see, is double. The vector AB you can write now in ij component, -5i plus j minus 3k. This is 2AB plus CB, you get it now, this one, -6i plus 2j minus 2k. And now by adding these two vectors, you get the answer. 2 times -5, -10 plus -6, -16i. And 2 times 1 is 2 plus 2 is 4j. And finally, 2 times -3 is -6 minus 2 is -8k. This is the answer. Question number 2. Given K and L 2 points, what is the distance between K and L? The distance formula is a direct application for using Pythagorean theorem. Just subtract the x component, 2 minus 4 all squared, plus -5 minus -11 all squared, plus 7 minus 4 all squared. Okay, just calculate this amount, we'll get the answer. 4 plus this is 6 squared, 36, plus 3 squared is 9. So the answer is square root of 36 plus 49, which is 7. Okay. Question number 3. Given K and L, the coordinate of M, the midpoint of KL is ABC. What is the value of A? The A is the first point. The midpoint, as you see, is x1 plus x2 over 2, and also y1 plus y2 over 2, and also z1 plus z2 over 2. This is the midpoint formula. So the midpoint here, just I need the A component, just add 2, -4, 2 and 4 over 2, which is 3. So A equals 3 here. Okay. Question number 4. Given P equal and Q equal to vector, if theta is the angle between P and Q, then cosine theta is A over 7. To find cosine the angle between two vectors, first of all, you find the dot product of the two vectors P dot Q, which is 1, -3, and 2. This first vector, dot or times 3, 1, -2. Write the answer now. 1 times 3, 3, minus 3, minus 4, which is -4. And after that, find norm P, or the magnitude of P, vector P, 1 plus 9 plus 4, which is root 14. The magnitude of Q now is square root of just to go to each component of the vector and square it. 3 squared is 9 plus 1 squared is 1 plus 4. The answer is also 14, root 14. So cosine the angle between the two vectors P and Q is P dot Q over norm P times norm Q. So the dot product here is -4 over root 14 times root 14 gives you -4 over 14. After simplification will be -2 over 7. So the A is equal to -2. Question number 5. Consider the line that passes through A1 to 1 and is parallel to this line. This is a direction vector. Direction vector. This is a point on a line. Which of the following is true? The vector equation, this is not vector equation. This form is called Cartesian form of the line or symmetric form of the line. R equals 3 plus 1. This must be the point. This is not the point, so this one is wrong. The vector equation of L is I plus 2 plus K. Yeah, maybe this one. Yeah, I plus 2 plus K plus a parameter T into direction vector. Is that a direction vector? Yeah, 3, 1, and 5. Yeah, 3, 1, and 5. So this answer is correct. Vector equations is not vector equation, even the equation is correct. This is not vector equation. Next one, vector equation R equal I. So this is not vector equation, of course. Okay, the part B in this question, when you solve it, part B, fill in the blanks. 31 A and B is a point on this line. It's easy to calculate this one here. If you take this point, the vector equation here is R is 1, 2, 1 plus a parameter T into the direction vector 3, 1, and 5. Now he wants the point 31 A and B lies on this line. The point 31 coming from 1 plus 3T, yes? 1 plus 3T, this part, as you see, 1 plus 3T is equal to 31. Yes, so the T now by solving this one gives you 10. So just to put the parameter 10 in this equation, you will get the value of A and B. Very easy. So I have 1, 2, 1, first vector, plus 10 into 3, 1, 5 gives you the value. The first one already given 31, the second one will be 12, and this is the value of A, and the value of B will be 51, as you see. If you put 10 times 5 will be 50 plus 1 is 51, and the 10 times 1, 10 plus 2 gives you 12. So the answer is A of A 12, and this is 51. Okay. Question number 6. The Cartesian equation of a line L that passes through the point 0, 1, and 2, and 2, 2, 5 is this. So what's the value of? First of all, if you are given 2 points, you want to find the Cartesian equation, you have to find the direction vector. First of all, so the direction vector here, direction vector, you can just write it AB, for example. Consider half point A and B, direction vector must be AB. AB or BA, no problem. So if you said AB, so B minus A, you just write 2, 2, 5 minus A, 0, 1, 2 gives you the direction vector 2, 1, and 3. Okay, so if you have a direction vector 2, 1, and 3, and one of these points is for example, you can say y minus 1, he takes this point. So the Cartesian equation is x minus x naught over A is equal to y minus y naught over B is equal to z minus z naught over C, such that A, B, and C is a direction vector. X naught, y naught, and z naught is arbitrary point or any point on a line, and x and y and z is the coordinate of any point given in a line. This is variables of the line. Okay, so the equation can be simply written in this form. So x minus, consider this point now, x minus 0 over direction vector here is 2 is equal to y minus 1 over direction vector here of the y part is 1 equals z minus 2 over direction vector here is 3. So as you see this part, so the value of b here, where is the b? The b must be 1, as you see in this part, and c is 3, and the k, by comparing z plus k and z minus 2, the k is negative 2. This is the value. Question 7, the distance from this point to this. To find the distance between a point in a space and a line, I have some steps. No need to give you the reason or the proof for the formula. I have a formula, I have to use it now. The distance between, consider any line, and I have point A. I want to find the distance d from this top point to line. You would just name any point B on a line. You just name any point by taking the parameter 0, 1, 2, 3, this parameter t, just make it anyone. Okay? You multiply this vector, the distance, I have a formula, is the magnitude of the AB vector cross v direction vector. Consider this line has a direction vector v over the magnitude or the norm of v. This is the distance. Let me start. So the vector AB, before finding the vector AB, just consider B point on L, the line L, this one. Simply you can take the initial point. Consider B now is 1, 3, and 1. Okay? This by taking parameter t is equal to 0. So the vector AB now is B minus A, yes? Is OB minus OA. So this point B, 1, 3, 1, just subtract from A, this point 1, 1, 0. The answer is 1 minus 1, 0, 3 minus 1, 2, 1 minus 0, 1. Okay, I found now this first part. The vector v already, the direction vector, the vector v already given here is the coefficient of parameter. So now I can find AB vector cross v, or we multiply normally the vector multiplication by writing the determinant I, j, and k, the unit vector in the main directions x, y, and z, and write the vector AB that we got it now, 0 to 1. And the vector v, as I told you here, is the direct coefficient of t. 1t here, this one, negative t means negative 1, and 2t, the coefficient is 2. So just write 1, negative 1, and 2. To find this product, or this value of this, of course, this is called vector product of two vectors, or cross product. You just what happened now, you just ignore this line and this line, that including I. Okay, you see now the coefficient, this 2 by 2 determinant or matrix, 2, 1, negative 1, 2, just multiply 2 by 2 like this. 2 times 2 is 4, minus 1 times negative 1 is 1. This is the coefficient of I. Okay, and after that j already is negative in the expansion. You multiply now 0 times 2 minus 1 times 1. Okay, so 0 times 2 0 minus 1. This is the j component, plus finally you can remove k by just I write it again. Okay, okay, I have I, j, and k, 0 to 1, and 1, negative 1, 2. Now if you want to find the k component, just ignore k, line and row. You have this, just multiply like this. 0 times negative 1 minus 1 times 2. This is the way we solve this part. So the coefficient of k 0 times -1 is 0 minus 2 into k. So the answer is 5i plus j minus 2k. Okay? Let me move this one a little bit down here. Okay, after finding AB times V, you have to find the norm of this part. So norm AB times V is equal to square root of 5 squared plus 1 squared 1 plus -2 squared gives you square root of 30. And norm of V, direction vector, remember the direction vector is this one, direction vector, square root of 1 squared plus 1 squared plus 2 squared, it doesn't matter 1 or -1 here, no problem, gives you root 5. And finally the distance from the point to the line is root 30 over root 5, which is root sorry, this is 6, I'm sorry. 4 plus 1 plus 1 is 6. So root 30 over root 6 gives you root 5. 30 divided by 6 is 5, so the answer is root 5. This is the distance between this line and this point. Okay, I hope everything will be clear now. The next question, 8, fill in the blanks. If the point Q lies on the line passing through the point P 7, 9, -4 and parallel to this vector, then the coordinate of the point Q is what? Very simple. The R direction vector 7, 9, or the equation, vector equation 7, 9, -4 plus the parameter T or any parameter times I 1 0 because we don't have J here, 4. Okay, this is really 7 plus T, yes, and this is 9, and this is -4 plus 4T. This is the vector equation of the line. This point I want to make it what number and what number, and 16. Just by equating these last two components, the k component, -4 plus 4t is equal to 16 to find the value of parameter. So 4t now is equal to 20, t is equal to 5. So just put t5 here, so 7 plus 5 is 12. This 9 is fixed number, okay? Because direction vector here, including I and k only, J is 0. Symmetric form of the equation of a line is x plus 2 over 2. And this one, given what you see now, what's the value of C if 12, B, and C is on this line? 12 is on this line. It means what? 12 is a point. 12 is the x value. Just put x here. This all gives you the parameter. You know, the Cartesian equation is the value of t, which is each of them is the value of t. So just put x at 12 now. So 12 plus 2 over 2 must be the value of the parameter t. So by solving this equation, you have 2t is equal to 14, implies t is equal to 7. So after making that, just put now y plus 3 over -3 is equal to the parameter 7 also. So y plus 3 is equal to -21. And consequently y is equal to -24. Very easy. And also put here z minus 4 over 7 as well is equal to the parameter 7. So z minus 4 is 49 and z is equal to 53, and this is the value of z. Very easy. Question 10, given L that is parallel to a vector this and pass through the point 3, -26, what is the value of C if this is line? The same equation. So the point, the parallel to the vector, this is the parameter. So 3, 2, and 0 into parameter T plus the given point here, 3, -2, and 6 gives you the value of any point on this line consider this point, 9, B, and C. This is the equation. So from the first component, I have 3t plus 3 is equal to 9. If you solve this equation, you will find t is equal to 2. So the parameter now is 2. 3 times 2, 6 plus 3, 9. Now, find this value t in the j component and k component, I, j, and k. Okay? So put t is 2 now. You have 2 times 2 plus negative 2 must be the value of b. Simply b is equal to 4 minus 2 is 2. Very easy. Yes? And I don't need to do this one. Okay? So in this part also, this is 2 times 0, 0 plus 6 is equal to c. So c is equal to 6. And this is the answer. Next question here. A line L is parallel to y-axis and pass through the point 12, 7, and pass through the point 12, 7, and 10. What's the value of a plus c if a, 11, and c is a point on this line? Parallel to y-axis means the y is different, maybe any number, but the other two components are fixed. So the a plus c must be 12 plus 10, which is 12 plus 10, which is 22. So the value of a plus c must be 22, the sum of the component 12 and 10. Okay, question number 12. Which of the following is true about the line? This line now, this is a given point. As I told you, the coefficient of the parameter or the vector multiplied with the parameter is called the direction vector of the line. The question now, the line makes what angle with a positive direction? Look at the coefficient now of the direction vector here. This direction vector, this one, negative I, this one. Negative I plus 3j plus 5k. The coefficient of I is negative means this line makes obtuse angle with a positive direction of x-axis. So it makes obtuse angle with positive direction of x-axis. Where is this one? Obtuse. Yeah, this one is true. The line makes an obtuse angle. But as you see, the j component and k component are positive. Positive means it's acute angle. Makes acute angle with direction of y and z. Okay? But with x, the coefficient of I is negative, so it's obtuse angle. So the line makes an obtuse angle with this one is wrong. Obtuse angle with a positive direction of z, wrong. Makes an acute angle with positive direction of y, yes. Lines makes an acute angle with positive direction of x, no, this one is wrong. We take the correct one. The line makes an acute angle with positive direction of z, yes. Okay. The next question here, what is the cosine of the angle of the line this? Let's make it a little bit smaller. What's the cosine of direction vector? Makes with a positive z direction. First of all, this is the direction a, vector a, for example. You find the norm of a, square root of, you have j and k only, so radical 3 squared plus 1, which is square root of 3 plus 1 equals root 4 is 2. The cosine, the angle contains the gamma, the angle makes with z axis or positive z axis, is the coefficient of k here is 1 over 2. This is the cosine of the angle. Okay, what is the cosine of the angle? This cosine. So if you want the angle itself, just write cosine inverse of half, you get the measure of the angle. Okay. The next question 14, which of the following lines is parallel to this line? Of course, the lines are parallel if one direction vector, for example, two lines are parallel. It means the direction vector here is a direction vector here is 2. If the lines are parallel, one of the direction vector is a constant times the other direction vector of the other line. So For example, A1 here, as you see, is 2, negative 3, 4 from the Cartesian equation. 2, negative 3, and 4. You have to find another line. Its direction vector is multiple of this. For example, look at this one, 8, 12, and 16. If you take 4 from this direction vector, 4 common factor, you have what? You have 2i minus 3j plus 4k. 2, negative 3, 4. Yeah, the same like this. So this line is parallel. This line is parallel to this one. Check this one. Here the direction vector 3, here 0, and because we don't have t here, parameter t. 3, 6, that's not parallel. Now this one, no. 1, negative 2, completely different. 1, negative 2, 7, not parallel. Here the coefficient, look, negative 6, 9, negative 12. This vector, if you took negative 3 common factor, what's happened here? You have 2, you have negative 3, you have 4. Yes, look, 2, negative 3, 4. Yeah, this line is parallel. This line also is parallel to the given line. Also here, the direction vector A is, or just name it V, or whatever you want. Negative 2, 3, and negative 4. Yeah, the same this one, but different. If you take negative 1 outside, have the same vector. Yes, no problem. This parallel, opposite direction, no problem, but the same. This also parallel. Here, the coefficient of parameter 3i minus 2 is not parallel. Okay. Last question I have today. These are two lines. If theta is an obtuse angle formed by L and M, then cosine theta is what? A over 14. What's the value of A? First of all, you have to find the direction vector of each side of each line. A1 is equal to the coefficient of t, direction vector coefficient of t, or coefficient of parameter. 1, negative 3, and 2. And A2 is equal to 3, 1, and negative 2. Okay, to find the angle, as you know, A1 dot A2, just a cross dot multiplication or dot product. 1 times 3, 3, plus negative 3 times 1 is negative 3, plus 2 times negative 2 and is negative 4. The answer is negative 4. Norm A1 is equal to square root of 1 plus 9 plus 4 gives you root 14. And norm A2 is equal to square root of 9 plus 1 plus 4 is also root 14. So cosine the angle theta between these two lines is simply negative 4 over root 14 times root 14 gives you negative 4 over 14, which is negative 2 over 7. He wants the same 14, so A must be negative 4. A is negative 4, and thank you so much. This is all for today. Thank you and goodbye.